Right, morning everyone. Welcome back to the stream. This is going to be a quick sort of 10-15 minute tutorial around how to efficiently delete data out of a large vertical table with hundreds of millions of rows, or well, millions and millions of rows. So I've got um, I've got a code set that I put into a paste bin, and if you look in the description of the video, there's a URL down there. That's the source code that you're going to need for this, or to test this out. Obviously, what you're going to need is a SQL Server instance, so you can download and install Developer Edition. That's free from Microsoft 2017. Install local instance on your machine, and off you go. Right, so some of the things that, you know, as it says in the description or the title of this one, page lock hell. So if you delete data out of a large table, you often lock pages or lots of pages, and you get deadlock transaction, or it blocks other transactions, and you can't do inserts, updates, and it just becomes a big old mess. So a very efficient way of doing this is to create small batches and then over and over and over again delete smaller batches of data, and this is what this tutorial is about. So I've got just want to show you, so I have a demo database where I have one large table. So I ran some of the sequential thing to generate 100 million rows of data, right? And the construct of this query or this table is fairly simple. We've got a clustered thing. Used to be good. I wrapped it in as a big int of or hash button, wrapped it as a big int because it's smaller. And then we got lots and lots of timestamps. So this is sort of supposed to represent some form of event table, right? And anyway, if you need to, so in real life scenarios, you will go, okay, well, I need to delete. So let's just do this. So new query. Oh, actually, well, we can do it in the same query. So if we want to go delete star from blah, and we look at the execution plan of this. Oh, sorry, no star. And we look at the execution plan. We go, okay, well, this is a big old table, gig of data, really, really, really expensive and massive operation, right? So then if we say, okay, well, we obviously don't want to delete all the data. We want to go, let's just take, delete everything where event time is smaller than, I don't know, let's say 1999, I don't know, anything that's smaller than the 31st of December, we got some millennium bug risk, right? We go, boom, and this thinks about it. And it goes, how big is this task? It's expensive, and we're shunting a hell of a lot of data, and it's just really, really, really bad, right? So now, what if we want to make things more efficient? What we must do is, we obviously, first things first, we want to support the sort of the delete statement or the where clause, right? So in this paste bin, we've got a clustered or non-clustered index. Sorry, that one. So if we grab that code and we insert this, so look at, you can see it moans about the missing index. So we just generate the missing index. Right, and this is going to take a little bit of time. Hopefully not too long of a time. It is, after all, quite a large table. Oh, it's moving. It's moving along. Not too bad. Lots and lots of throughputs. Happinesses. And it will be done soon. Let's right, so this is obviously the beauty of yeah, live streaming stuff. There we go, done. Took a minute and a bit. So if we remember, it was this one complained about missing index, so we're going to run this now. Oh, faster, no moaning. And the operation is now more exact, but still expensive. 2,000 subject cost 2,119. Hellishly expensive, right? So you can use top clauses in delete statements. So what? First of all, one of the reasons why we start sorting stuff, right? So if we delete, and we'll get to this now. So that I found something on Brent as well that was quite interesting. That talked about you know, you create views that you delete out of, because then you can sort views and that sort of thing. Because if you're worried about deleting sequentially from the tail end, the oldest records to your newest records, right, in a set, and you need a continuity, you need them to be sequentially deleted. You can create a view with a top clause that has an order by statement, right? And we're going to do that just now. And the way to do that, it's all in the code from the paste bin. So let me just bring that code up. Right, so create a view. Right. Obviously, it's not always practical to do this, but yeah, this is a way of solving it. So here's a view that takes, serves up the last 1,000 or 1,000 records in a chunk, right? And we've ordered this by the event time table. So this will just, sorry, already created the view. Let's just drop the view, recreate it, do it proper demo style. Delete. Want to make sure everything works and that you see that I've used the same code. But let's just generate the view. There we go. View is created. Now we looked at, we looked at. Let's just remark out the stuff we don't need or delete it. So when we ran this, right? When we looked at subject cost for this, it was at 2,119. Okay, if we go and use the view, so I just want to grab that out. So if we change that to use the view instead, so we had our, look, this is only 1,000 rows of data, but 2,119, right? Massive. And we go here and we say, let's have a look at that one. That becomes a lot smaller. The amount of data we're shunting is, it's small, not so much data, okay? So it's great, because if we delete like this, we will delete ultimately only 1,000 rows, and that kind of doesn't work that great. The beauty of this is, though, that the deletions will be sequential from the oldest record to the newest. So you will not randomly start deleting rows in a batch, or this will be sorted, right? So if you care about having sequential deletes in your batch deletes, then this is great. Right. So I mean, if we run this, boom, done, really quick. Lots of small deletes. We're really happy, and you think, okay, well, oh crap, how do we sort this out or make this faster? So I've got another way of deleting 12 months worth of data in batches of 1,000. So this is ultimately about 200,000 rows of data. What I've done is I've changed to use from using the view. I've got maybe we should use the view. Tell you what, let's use the view instead, just to stay true to the sample. Need to find my code. Right there. Let's just go and remark this code out. We will just use the view instead of the table. So we go here. Right. So what I've done now is I've created this. Well, the top clause is also not required anymore because guess what? It's not required because we have top clause. We control it in the view. We're going to show you how to do this more efficient. Well, the same way, but not using a view as well. Right. So what we do here is we want to delete up until a datetime point, and that one grabs the last 12 months and from this large table. Right. So we go, what's my minimum event datetime, which will be whenever it was 19 sometime, and it goes add 12 months onto that. Right, and that becomes our 2 point or our upper limit. Okay, then we declare some variables, right? So we a row variable, right? We set it to 1, and we go while row variable is greater than 0. And what we're going to do is we're going to measure the row counts, right? So we grab the row counts in our deletes. So we do a delete from update set row count end, and until we hit a row count of 0, that will that will remain always true, so it won't break, right? And then we delete it that way. Now I know for a fact that this is we can do the maths quickly on screen. So the view generates the view or the code generates a large table with a row per minute from a certain date, right? So in an hour we have 60 minutes an hour, so it's 60 for an hour times 24, so that's per day. And just hold on a second. Then every day or every week. Well, hold on. So 12 months is, call it 52 weeks. So times 7, right? So that's minutes in a week times 52. That's okay. So it's quite a large number. It should be about 500,000 rows, right? So we need to alter this view. The view can't be that small. Just give me a second. Sorry, drop and create a new query editor. Right. So let's just change that to 10,000 rows. Right. Or else we're gonna have so many iterations in this thing. Right. View's been updated, and we can see that if we go here and we say, so if we just take this away, you'll see that in the, we just check the execution plan, it has updated. So you can see it's 10,000 rows. But it's still 0.4, massively small execution. However, for 500 million rows of data, this is gonna have to cycle a good couple of 500 times, right? 50, 60 times. Okay. Am I getting that right? Yeah. 50 odd times, right? 10,000 rows, 500,000. So if we run this code, so let's walk it through. We declare a date. We set the date to smallest date plus 12 months. We set up our row counter. We set it to 1 while the row counter small is greater than 0, delete from the view that now has 100,000 rows in it, where the event date time is greater than 12-month mark. Right, update the row count to the R variable and run until complete. So let's just execute this and see how happy it is. Right. So actually, yes, let's run it. So we're gonna actually, let's not run it. Let's do the same thing, but just use the slot in the table. So I wanna show what the delete statement would look like if we only using the table. So if we don't use the view, right, and if we were to do this, and we go, let's view the execution plan and then look at our deletes, you can see 4,800. This is a massive query. It's going to cost a lot, but it's okay, because guess what? We've got this view that limits it, or well, we're limiting the delete the batch sizes, and so that's going to run for long. It's going to block a whole bunch of transactions. Now, when we run the loop, what ends up happening is that we run it. It will take a bit of time, but it's small chunks of data, and it's not gonna. It's gonna give breathing space for other processes to do stuff. Right. So if we now execute this, well, let's look at the execution plan first, and you can see, tiny point. It's like they're tiny, and then it's just gonna cycle over and over and over again. Right. So let's run the stuff. What? What's happening? What's happening? What's happening? What's happening? See how quickly it goes. In the meantime, I'm sure we can open up a new query and go select top 100 from what was that table? So we're done. That took a whole bunch of 12 seconds. Holy moly, that was quick. Right, now if we try the same thing by just running the straight delete, so if we go take that, so that was 12 seconds in a loop, and the server could breathe lots. And then we go, let's just use that from the table, right? So this one, 12 seconds, really efficient, and lots of breathing space. Run the same statement, but delete straight from the table with just a limiting variable, without chunks. We go, let's sit and wait. Let's try to run a query against this table. Wait, I had a new query. Oh, we're done. It was faster. No, that was a demo fail. That was a demo fail. Why was that a demo fail? Okay, anyway, we're going to try to do stuff in between. So let's just set that up too. Let's try to delete a bit more data. So let's just run this again. And you can see, oh, we're not getting any data back. Oh, we have to wait for the delete to finish. Oh, this is terrible. Delete finished. Right. Let's remark out the loop. Let's run, I think this whole thing is just remarked. Yeah, let's run this whole, so now we run the loop instead of just a straight thing. Start running it, and then oh, look at that, we're getting data out. We're not waiting for the SQL because it's giving us time to breathe. So here's always the benefit of running in batches. You're not blocking all the other stuff. Yeah, page locks are not a problem. And we're stressing this out by running queries. Oh, lots. Give me queries. schema queries. Let's put an order by clause into here as well. I'm going to order by the ID column, which is a clustered index, so it will be really efficient. So order by ID descending. So we want to see the last records, right? Right. So these are the last 100 records, and it's not descending. It's those ones, right? I mean, it's ascending, not descending. Okay, so if we run this again, which, right, you can see we can still run order by. So we see, can you see the data's changing? You can see the dates are changing because we're deleting data. We're in 1982, right? So this is a very, very efficient way of getting data out of tables, large tables. And I mean, this is a large table. I mean, let me just show you. Well, we'll do this. It'll be quicker, or more informative at least. So we go here, properties on that guy, and you can see we're down to 96,800,000 rows, right? It is big. Cool. So I hope lessons learned, or what is the takeaway from this? So when you're deleting large amounts of data, don't just go delete from table where some filter is whatever it is. Rather, if you don't care about creating a view that does things sequentially, you don't have to create the view. You can bake that into your delete statement. So you have your order by clauses there and your top clauses there. If this is common maintenance task, then create a view for it. If you're doing this through storeproc, hey, you don't have to create the view, just drop it into storeproc, and then you can also maybe feed in how many rows you want in your batch sizes. Okay. However, anyway, if you build it like this, it's delete in small batches, and especially if you're touching systems that are transactional. So you're going to have applications that are going to pull data, other processes, ETLs, transformations, reports, whatever it is, going to go and either suck data from this table or insert data, or update data, or do whatever. Your chance of hitting deadlocks is minimal. Your chance of hitting page locks is small, and the wait times, they're under control. Sure, it takes a little bit longer than doing a straight batch delete, but at least you're not locking a massive range. You're locking small ranges of data, and it's really efficient. So, hope this has been informative, and I hope you learned something. So, yeah, you guys have a good day, and catch you next time. And also, if you want to see more of this kind of content, please like and subscribe. Cheers.
I am sushi, no one can get me.